So we are. This is still section 8.2, part 2, and we're going to do 30, 60, 90 triangles. All right, so let's start with an equilateral triangle. Here is an equilateral triangle. I'm just going to go the other way. There we go. All right, so what do we know about the sides of an equilateral triangle? They're all equal. So that's what equilateral means. So for this one, I'm going to start off with side length 2. 2, 2. What do we know about the angles in an equilateral triangle? They're all equal as well. If all the side lengths are the same, all the angles are the same. What are 3 equal angles that add up to 180? 60. So each of these is a 60-degree angle. And I'm going to leave the one at the top. Because what I'm going to do is draw in the altitude of this equilateral triangle. So the altitude makes what angle with this opposite side? 90 degrees. There's a 60-degree angle. There's a 90-degree angle. What does the altitude do to the angle here? Cuts it in half, bisects it. So that makes this angle 30 degrees for these to add up to 180. So there's our 30, 60, 90 triangle. A 30, 60, 90 triangle is half an equilateral triangle. So this altitude bisects this angle. What does it do to this side? Cuts it in half. So if this side is 2, this piece of it is 1. Now for this 30, 60, 90 triangle, the way I'm going to label the sides is 2 is the hypotenuse. I'm going to call the side across from the 30-degree angle, the side across from the shortest, from the smallest angle, the short side. And the side across from the 60-degree angle, we're going to call the long side. So just starting off, what do we see? How are the short side and the hypotenuse related in this particular one? The hypotenuse is how many times bigger than the short side? 2. Because we're cutting this side in half. Well, let's find the long side. So we're going to use our Pythagorean theorem. So I get the long side, let's call this side A and this side B for our Pythagorean theorem. And this would be C. So A squared plus 1 squared equals 2 squared. So A squared plus 1 equals 4. Subtract 1 from both sides, I get A squared equals 3. And to undo the square, what do? What undoes a square? Square root. There we go. So A is the square root of 3. So the long side, yeah, Lee?
Well, how'd you get like A squared plus 1 equals 4?
1 squared is 1, and 2 squared is 4. So I'm just using the Pythagorean theorem. Hello?
Hello, Mr. Wiener. Can I interrupt?
All right. So what we have for this one is the short side equals 1. The long side equals the square root of 3. And the hypotenuse equals 2. Well, let's make this, let's do it for a side length, and I'm just going to do one more. I'll do less than I did for the squares, because I think we'll see the pattern here. If the hypotenuse, if the length, the side length of the equilateral triangle is 4. Yes? Because this altitude cut this side of the equilateral triangle in half. Okay? All right, so if the side of the equilateral triangle is 4, what does that make my short side? 2. And we're going to find the long side. So for this one I get a squared plus 2 squared equals 4 squared. So a squared plus 4 equals 16. Subtract 4. You get a squared equals 16 minus 4 is 12. Undo the square by taking the square root. So a equals the square root of 12. And we can simplify that because 12 is 4 times 3. Square root of 4 is 2, and I get 2 square root 3. So here I get the short equals 2. The long equals 2 square root 3, and the hypotenuse is 4. So what would you guess is going to happen if I made the long side, or the hypotenuse, 6? The short side would be 3, and the long side would be,
4 square root 3.
let's see. The short side is 1, the long side is 1 times the square root of 3. The short side is 2, the long side is 2 square root of 3. So it would be 3 square root 3. Yeah.
But how do you know like which is A, B, and C?
C is always the hypotenuse, and the other two I could label either one A or B. Okay. So this leads us to our 30, 60, 90 theorem. So we see this pattern happening with the triangle. The hypotenuse is twice as long as the short side, and the long side is square root of 3 times as long as the short side. So our 30, 60, 90 theorem says that in any 30, 60, 90 triangle, the hypotenuse is twice as long as the short side. And the long side is square root of 3 times as long as the short side. And we got to this by dividing an equilateral triangle in half to get our 30, 60, 90 triangle. 30, 60, 90 triangle is always half an equilateral triangle. So that's why the hypotenuse and the short side are related this way. The hypotenuse is twice as long because the hypotenuse is the whole side of the equilateral triangle. The hypotenuse is only half of it. And then the Pythagorean theorem lets us figure out that the long side is square root of 3 times as long. So this kind of sounds a little more involved than 30, 60, 90 triangle. There's really just one other thing we're remembering. So what we're going to do is draw a picture like we did for the 45, 45, 90 to help us remember. All right, so questions about our theorem and how we came up with this idea. All right. So for 30, 60, 90 triangles, the short side is the key. So here's our picture. Here's my 30, 60, 90 triangle. And we're going to label our sides, kind of like we did for the 45, 45, 90. This is the hypotenuse. The short side is always across from the 30-degree angle, across from the smallest angle. And the long side is across from the 60-degree angle. All right, so we're going to say to go from the short to the hypotenuse, multiply by 2. To go from the short to the long, multiply by the square root of 3. That's all there is to it. And then to go the other direction, if we know the other sides, so let's draw another triangle here. And again, my 30 degree angle, my 60 degree angle, and my 90 degree angle. Short side across from the 30 degree, long side across from the 60 degree, hypotenuse across from the right angle. Now to go the other direction, to go from the hypotenuse to the short side, what's the opposite of multiplying by the square root? Multiplying by 2. Divide by 2. And to go from the long to the short, opposite of multiplying by the square root of 3, divide by the square root of 3. So that's all you have to remember for 30, 60, 90 triangles. Your short side's your key. To go from the short to the hypotenuse, multiply by 2. To go from the short to the long, multiply by the square root of 3. To go from the hypotenuse to the short side, opposite, do the opposite thing. Divide by 2. To go from the long to the short, we divide by the square root of 3. So our short side is our key. We could write rules to go from the long to the hypotenuse or from the hypotenuse to the long. They get more complicated. It's easier just to remember these two things and always try to get to the short side to find your other sides. And if it helps you remember, the short side has to be shorter. So to get to the hypotenuse of the long side, we're going to multiply. Multiply to make it bigger. We're multiplying to make it bigger. The short side is smaller, so we're going to divide to make it smaller. That might help you remember which way to go. The questions there. All right, all I want to do is a couple of examples. This is really all that we're doing today, is just learning these rules about 30, 60, 90 triangles, and that's all there is to it. Okay. So we'll do an easy one first. Here's my triangle. We're along here. There's my 60 degree, 30 degree, 90 degree, and we have that side's 5, and we want to find missing sides. So what I'm going to suggest is, just like we did for the Pythagorean theorem and for 45, 45, 90s, let's label our sides. So is 5 the short, the long, or the hypotenuse? It's the short, because it's opposite the 30 degree angle, opposite the smallest angle. This side, hypotenuse, opposite the 90 degree angle, and that makes this side long. Long side is always across from the 60. All right, so let's do the easy one first. To go from the short to the hypotenuse, what do? Multiply by 2. So the hypotenuse equals 5 times 2, or 10. And to go from the short to the long, multiply by the square root of 3. So the long side is 5 square root of 3. And I'm done. So because this one they gave us the short side, that's the only one we know. So we have to use that one to get to the other side. So it depends on how the problem is set up. But our short side is always our key. If we have our short side, then we're home free, because we just do these two things. If we have one of the other sides, then we want to find the short side first. Okay? And we'll do one of those next. All right, questions here? All right, so here's our triangle for our next example. And we want to find the missing sides here. So let's label our sides. So what side do we have here? We have the long side, because it's opposite the 60-degree angle. What side is this one? That's the short side. Now on this one they didn't give us the 30-degree angle, they just gave us a 60-degree angle. But if this is 60 and that's 90, this one has to be 30. And so that makes this side the hypotenuse. So we said our short side is the key. So let's find our short side first. Long to short. What do we do? Divide by the square root of 3. So our short is 6 square root 5 divided by the square root of 3. And then what do we do to that answer? Simplify. We rationalize the denominator. So multiply by the square root of 3 over the square root of 3. The numbers inside the square roots I can multiply together. So on the top I get 6 square root 15. And the square root of 3 times the square root of 3 is, I can combine them inside the square root. So square root of 9, which is 3. And now I have these two numbers outside the square root. I can divide them. So 6 divided by 3 is 2. So I get 2 square root 15. So the short side is 2 square root 15. And now to go from the short to the hypotenuse, what do I do? Multiply or divide? Multiply. It has to get bigger, right? Multiply. So the hypotenuse is 2 square root 15 times 2. And I can multiply the numbers outside the square root. So I get 4 square root 15. So this was one kind of like you were talking about earlier, where you said, how do you know which way? So we always want to find the short side. If we don't have the short side, find the short side, and that'll let you find the other side. And the other reason I did this one is because, like with the 45, 45, 90, a lot of students think that a square root of 3 is always going to be in the answer somewhere. Not necessarily the case. Here we have a square root of 5 and a square root of 15. So we don't always end up with a square root of 3 as part of one of the sides. Just depends on how the problem is set up. All right, let's do one more, and then we'll be done. So here's my triangle for this one. And now we have that side is 8. So let's label our sides. Which side do we have here? Short, long, or hypotenuse? We have the hypotenuse. This side is short, long, short, or long? Short. Across from the 30-degree angle, so that makes this the long side. Our key is the short side, so we want to find the short side first. So to go from the hypotenuse to the short side, divide by 2. So the short, 8 divided by 2, or 4. And to go from the short to the long, multiply by the square root of 3. And I get that the long equals 4 square root 3. We found the short side was 4. And that's all there is to it. So basically, 2 rules to remember. We either multiply by the square root of 2, so for 45, 45, 90, we either multiply by the square root of 2 or divide by the square root of 2. For 30, 60, 90, we either multiply by 2 or multiply by the square root of 3. Go the other way, we divide. So just a few rules to remember about our special right triangle. I did want to say special right triangles, they're pretty important. You'll see special right triangles again in Algebra 2. We'll do a little bit of trigonometry, but we won't do trigonometry that involves a special right triangle. In Algebra 2 you do a little bit. And then in pre-calculus you'll see special right triangles all over the place when you study trigonometry. The 30 degree, 60 degree, and 45 degree angles are really important angles in trigonometry. So you'll see these special right triangles again and again and again. So this idea of the angles and the relationships of the sides is really important and something that will keep coming back. All right, so let me put today's homework up. Very small amount of homework there.